afternoon. We define parabola as the set of all points on the plane equidistant from a fixed point called the focus and a fixed line called the directrix. This afternoon, we shall obtain an analytic representation for the definition of the parabola. In other words, we want to convert this definition into an equation. Let's consider this figure, a parabola that opens to the right. Suppose the vertex has coordinates hk. Let us denote A as the undirected distance from the focus to the vertex. By the definition of the parabola, the distance from any point on the parabola to the focus must equal to the distance from that point to the directrix. In other words, if FV is equal to A, then VT is also equal to A. Thus, the coordinates of the focus will be H plus A, K, and the equation of the directrix would be x equals H minus A. Now let's have another point on the parabola aside from the vertex. Let's say P with coordinates xy. Let's draw a perpendicular line PQ from P to the directrix x equals H minus A at Q. So the coordinates of this point would be H minus A, Y. Now by the definition of the parabola again, we can say that the line segment PF is equal to line segment PQ. For us to be able to find the equation of this parabola, we can use the distance formula. For line segment PF, we can denote point F as x sub 1, y sub 1. For point P as x sub 2, y sub 2. For line segment PQ, we can denote Q as x sub 1, y sub 1. Now we are ready to find the equation by using the distance formula. So we'll have the square root of, so we'll have x sub 2 minus x sub 1 quantity squared, so that would be x minus h plus a quantity squared plus y minus k quantity squared equals, since this is a horizontal line which is parallel to the x-axis, we can just subtract their abscissas. So that would be x minus h minus a. Then let us solve this equation and let us simplify. Since we have here a radical sign, get rid of that. So by squaring both sides, square both sides. So we can get rid of this. Then square this. So we'll have x squared minus 2x h plus a. Then the square of h plus a. So plus h squared plus 2ah plus a squared. Then plus, copy this, y minus k quantity squared equals. Then we have here a trinomial. So we will have x minus h plus a quantity squared. Let us simplify the left-hand side of the equation. So we'll have x squared minus 2xh minus 2ax plus h squared plus 2ah plus a squared plus y minus k quantity squared equals the square of this trinomial. So square each term first. So you'll have x squared plus h squared plus a squared. Then minus 2 times xh, then plus 2 ax, then minus 2ah. Okay? Then simplify further. Okay? We can use the addition property of equality to simplify this equation. So we can cancel x squared. What else? We can cancel negative 2xh, negative 2xh, because if you're going to transpose to the other side, this will be 0. Aside from that, we can also cancel h squared. What else? You have a squared. Okay, so what's left in the left-hand side would be negative 2ax plus 2ah plus y minus k quantity squared equals, you have here 2ax minus 2ah. So simplifying further, we have y minus k quantity squared equals 2ax plus 2ax, will have 4ax, 2ah, negative 2ah minus 2ah, will have negative 4ah. We're almost done. Therefore, since 4a is common here on this side of the equation, factor it out. So 4a, factor out 4a times the quantity of x minus h, that is equal to y minus k quantity squared. This is the equation of the parabola that opens to the right, whose vertex is at hk, and the directrix is parallel to the y-axis.